Hi there, excellent to see you. Mr. Sutton here with the Pre-Cal Honors 4-6 Extra Practice Number 2 solutions on exponential equations. On this problem, first thing I'm going to look at is to see if we have common bases. 19 and 93 do not have a common base, so we're going to have to use logarithms. My exponential term, 19 to the x, is already isolated, so I can just take the log of both sides to use my pop-out rule. That'll give me x log of 19 on the left and log of 93 on the right side. Then I just have to divide by log of 19, and whatever that comes out to on the calculator will be my answer. So, plugging that in, it looks like we're going to end up with about 1.54 if I round that off. On this problem, I noticed that 3 and 1 over 81 are both powers of 3, so I can use the common base method on this one. 3 is good the way it is, but 1 over 81, I can rewrite that as 3 to the negative 4. And now I have 3 to the something equals 3 to the something, so I can cancel out those base 3's, leaving me with just the exponents. 3r minus 3 equals negative 4. Next, just solve for r here. So I'll add 3 to both sides. That's going to be negative 1 on the right side. And then dividing by 3, I end up with r equals negative 1/3. For this problem, I'm not really sure which approach I'm going to need to use, but let me at least start by isolating the exponential term, and we'll go from there. So adding 2 to both sides, we've got 99. Divide both sides by 9, and that's going to be 11, which we already have on the left side. So we've got 11 to the x plus 7 equals essentially 11 to the 1. Well, I can cancel out those base 11's now, and I can just write x plus 7 equals 1. So a common base method, it turns out, actually works on this. Subtracting 7, we get x equals negative 6. For this problem, it doesn't look like we're going to be able to use the common base method. So let me go to logarithms. Before I can do that, though, I need to isolate this exponential 8 to the x term. So I'll do that by dividing both sides by 12. And you're going to use the calculator anyway, so there's no point in reducing this. Next, let me take the log of both sides. So I can write x log 8 using the pop-out rule equals log of 76 over 12. That's all one big log right there. And now I'll just divide both sides by log of 8 and plug all of this into the calculator. So to do all of this on the calculator, I'm going to use some nested fractions. I'm going to do alpha y equals and pull up my n over d option here to get a fraction. Next, I'm going to do log of, and I'm going to do that again, fancy fraction of 76 divided by 12. Close that parentheses. And then down here we've got log of 8. Press enter for all that stuff. It's about 0.89 when all is said and done. To get anywhere on this problem, I'm going to have to use logarithms. Common base, unfortunately, is not going to help me out here. So let me start by isolating the exponential term by dividing both sides by negative 6. So I'll just put everything over there on the right. I'm not going to actually bother seeing what it comes out to because I'm going to use the calculator later on anyway. Now I'm going to take the log of both sides. Now, I usually use log base 10 on these problems, and we happen to have base 10 right here. So instead of writing p times the log of 10, well, I know the log base 10 of 10 is just 1. So on the left side here, I'm actually just going to end up with p, and I'll just have log of all this stuff on the right side. So let's plug all this into the calculator now. And if I take the log of all this, I mean, these negatives kind of make me nervous, but a negative divided by a negative is a positive. So this is actually going to work. It all comes out to about 0.79. On this problem, it turns out I can actually use the common base method. 6, 216, and 6, those are all powers of 6. The only one I really need to change is the 216. I'll turn that into 6 cubed. And now let me just use my exponent rules to clean up the left side here. 6 to the a minus 3 times 6 to the 3, I'm going to be adding the exponents. So that's just going to be a to the negative 3 plus 3, or just 6 to the a. If that equals 6 to the negative a, I can cancel out those 6's, leaving me with just a equals negative a. Add the a to the other side, we've got 2a equals 0, so that means a must itself be 0. On this problem, one thing I notice is that 1/2 and 8 are actually both powers of 2, so let me rewrite these as powers of 2. 1/2 is really 2 to the negative 1, and 8 is really 2 to the 3rd. Let me clean up the left side here. Let's see, we can multiply these exponents together. So this is 2 to the x minus 4. And now I can cancel out my 2's, leaving me with the equation x minus 4 equals 3. So that means then that x must equal 7.